Hi, this is Alex from devstories.eu, learning DSPy, episode 9 of 15. Manually picking the best examples to put in a prompt is tedious and prone to bias. You guess which examples matter, hard code them into your strings, and hope the model pays attention. DSPy actively synthesizes, tests, and selects the perfect demonstrations for you. This process is automatic few-shot learning, and DSPy handles it through 3 specific optimizers. The simplest approach is labeled few-shot. You provide a set of labeled training examples. The optimizer randomly selects a subset of these input and output pairs and inserts them directly into your prompts as demonstrations. It gives the model a basic pattern to follow. This works well if your training data exactly matches the intermediate steps your program needs. Usually, it does not. This brings us to BootstrapFewShot. A common misconception is that BootstrapFewShot just randomly picks examples from your training set. It does not. It actively generates intermediate reasoning steps that never existed in your raw data. Here is how the bootstrapping process flows. The optimizer requires a teacher program. By default, this is just the unoptimized zero-shot version of your own program. The teacher runs through your training examples. For each example, it attempts to generate an answer. DSPy then passes that answer to your evaluation metric. If the metric says the output is correct, DSPy saves the entire trace of that successful execution. This trace includes the input, the output, and crucially, any intermediate work the program did to get there. Consider a sentiment classifier. Your raw dataset contains only customer reviews at a positive or negative label. Your DSPy program asks the language model to use chain-of-thought reasoning before outputting the sentiment. When bootstrapping, the teacher reads a review and writes out a paragraph of reasoning before guessing the sentiment. If the final guess matches the true label, that generated reasoning is considered successful. The optimizer collects these successful traces. It takes 4 of them and injects them into future prompts. Your zero-shot classifier is now an expert 4-shot classifier, complete with synthesized reasoning steps. BootstrapFewShot stops once it finds enough successful traces, but the first successful traces are not always the best ones. Here is the key insight. BootstrapFewShotWithRandomSearch solves this by running the entire bootstrap process multiple times. Each time it pulls a random subsample of your training data. This creates several different candidate sets of few-shot demonstrations. The optimizer then takes all these candidate sets and evaluates them against your validation data. It tests which specific combination of demonstrations yields the highest overall score. It discards the weak sets and keeps the mathematical winner. The true power of automatic few-shot learning is not just saving you time writing prompts, but discovering successful intermediate reasoning paths your dataset never explicitly contained. Thanks for listening. Happy coding, everyone.